Hello my dear students, this is Akash SD and welcome to the ASD physics classes. Hope so doing really great. So students, in this class we are going to learn about the satellites, and you know about the satellites very well because the moon is one of the natural satellite of the earth. Like that, so many satellites are there, those revolves around the planet. Okay students, so let's start one by one. So the thing is that satellite. So what is the satellite? Let's see here. A light body revolving around a heavier planet due to gravitational attraction is called a satellite. After that, the path of these satellites are elliptical with the center of planet at a focus. If difference in major and minor axis is not large, then we can assume that what a circular orbit is there. And here we can see moon is a natural satellite of Earth. So here students, remember that here if the satellite is revolving in a which orbit? Elliptical orbit. Then planet will be one of the focus, because in ellipse how many focus is there? Two focus is there, and the planet will be where? At one of the focus. But if in case the satellite is revolving in a which orbit? Circular orbit. Then what will happen? That the planet will be at the center. So most of the time what happens? The satellite revolves in a elliptical orbit only. That we will learn in a Kepler's law. Lot of basic things are there. Okay, but first in this topic we will consider the satellite is revolving in a which orbit? Circular orbit. Okay, so let's go ahead. Next one here. So students, what is the essential condition for the satellite motion? See please, first one, the center of satellite's orbit should coincide with the center of the planet. Very, very important. Next one, plane of the orbit of satellite should pass through the center of satellite. Okay, so here students, I have taken here, let's take here, this is the one planet is there, and this planet is having center. No, here center is there. No, so what will happen that here, if in case any satellite is revolving like this, okay, so what will happen that here, if the satellite is revolving like this, in this situation what will happen? The center of the satellite orbit, you can see it please, the center of the satellite orbit and the center of planet is coinciding. That means this is which kind of orbit is there? This is the stable orbit. Similarly, if I talk about the second situation here, now here also one planet is there and we can tell this is the center. Now what is happening that here, let's take satellite is revolving like this here, like this. Then you can see very well, if we see the center of the orbit of the satellite, this is the here center of the orbit of the satellite. So you can see here this center and this center is not coinciding. In this situation, which kind of orbit is there? This is called unstable orbit. The satellite can never revolve in an unstable orbit. Then what will happen that here, even if the satellite is revolving in a unstable orbit, automatically it will come to the stable orbit. How it will come here? Just see please. Here let's take for example satellite is there. This satellite will experience one gravitational force here. Is it? And this gravitational force is having two components. No? One component this side and one component this side here. This one I have told which component? For example, vertical component. And here I have told which component? Horizontal component. So what will happen that here, because of this component of the force, what will happen? The slowly orbit of the satellite will shift and again it will come to the stable orbit. That means satellite automatically they will revolve in a which orbit? They will always revolve in a stable orbit. Remember that here. And these conditions are very important. It will come in a exam. Next one students, we are going to see some basic terms here related to the satellite motion. First one, let's see please. Very easy, orbital velocity. What is this? Let's please. Let a satellite of mass small m is revolving in an orbit of radius r with speed v0. So the required force for satellite motion will be provided by force of gravity. As shown in diagram. So students, here I am using the term planet only. Number of times we can use Earth as a planet also, now by default. So let's take here, this is my planet, okay, and this planet is having what? This is the center here, see, and its radius is r, okay. Now after that what is happening that here one satellite is there. This is the satellite, and let's take this is revolving around the planet, okay, and the radius of the orbit of the satellite is small r. If in case height of the satellite is h, What I'm telling here, the height of the satellite is how much? The height of the satellite is h. Then what we can tell here, we can write here small r equal to r plus h. This is always applicable. Now students, after that what is there? Let's take this satellite is having speed how much? V naught. Even if the satellite is here also, for example satellite is here also, speed how much? Speed is V naught. Circular orbit means what will happen? The speed will be same. Direction will keep on change, but the speed will be same. So what will happen that here, this satellite is having how much mass? As I told you, this satellite is having how much mass? Small m. And the mass of the planet how much? Capital M. Now you know very well from the Newton's law of gravitation, two masses will always attract. That means this satellite will experience one gravitational force, and as this is happening between the planet and the satellite, planet is very heavy, that's why we will tell the name what? Force of gravity, is it? And what will happen that here, this gravitational force will act as a centripetal force, so that the satellite will revolve in a which path? Circular path here. Okay, that's only we have told here. The required force for satellite motion will be provided by force of gravity. So we can tell students mathematically this centripetal force will be provided by the which one? Gravitational force here, or force of gravity. Centripetal force formula here, m v naught square by r is equal to gravitational force gmm by r square. Okay, now what are the things will cancel out? Small m cancel. That means the orbital velocity will not be depending upon the mass of the satellite. After that what will happen here? From this r, one r will cancel out. That means we can tell here v naught square equal to gm by r. Now I will write here, what is there? V naught square equal to gm by r. Hence orbital velocity is given by square root of gm by r. This one depends upon the mass of the planet, not depend upon the mass of the satellite. Next one please students, important points. So what are the important points? If satellite is very close to the surface of Earth, very close to the surface of Earth, what will happen that here? That means value of h will be 0, not exactly 0, approximately 0. Then what we can tell here? We know small r equal to how much? R plus h, and this value will approximately become how much here? Because h is 0, that means it will become how much here? Capital R. In this situation students, this orbital velocity is given by what? Just put here root gm by r. Okay, even sometimes you can just multiply with r, divide by r. And what is gm by r square? This is small g, so we can write here this root gr also, is it? And if in case this is the earth, then this value is used to be how much? 8 km per second here, and this g value how much? 9.8 meter per second square, and capital R 6400 km for the earth, approximate value. Please remember that this thing. Next one students, see please, if orbital velocity is increased by 41.4%, then it will escape from the gravitational field of the earth. Here we are talking about the earth. So you know very well what is the initial escape speed, v naught t, if the satellite is close, so what we can tell here? Root gm by r, as we have seen very well. And you know very well what is the escape velocity? Escape velocity formula, root 2 gm by r. So please remember that here, initial is this one, but if anyhow the final is becoming this one, then in this situation students, the percentage increase, percentage increase in speed, it is given by, you know very well, v naught f minus v naught I by v naught I into 100. After that what will happen that here? Just simplify this, v naught f by v naught I minus 1 into 100. Now students, if I just put here the values here, what is the value? V naught f by v naught I, what will come here? If we take the ratio here, it will come root 2. So root 2 minus 1 into 100. Root 2 value how much? 1.414. So when you will simplify this here, it will come as 0.414 into 100. And how much coming here? 41.4%. Remember that directly it will come in exam. Okay students? Good. Now if we talk about here in terms of the kinetic energy. So see please, if kinetic energy is increased by how much? 100%, then again it will escape from the gravitational field of the earth. Previously we have talked about the speed, now we are talking about the kinetic energy. So again I will tell here, percentage increase in kinetic energy. You know very well what is the kinetic energy formula? No, you know very well, but I will write in this form here. K naught F minus K naught I by K naught I into 100. Now we can write here, see please, k naught f by k naught I minus 1 into 100. And what is the kinetic energy formula? You know k equal to half m v square. So what will happen when you will take the ratio half m, cancel out. So it will become here, students, v naught f by v naught I whole square minus 1 into 100. And previous also we have seen very well, v naught f by v naught I, how much? Root 2. But here it will become here root 2 square. No, so here please, root 2 square minus 1 into 100. And when you will simplify this, how much coming here? 100%. That means in terms of speed, 41.4%. In terms of kinetic energy, how much? 100%. Okay, great. Next, students, very easy. We are going to see the time period. What is this? Very easy. It is the time taken by satellite to complete one revolution around the planet. You know very well. So, students, you know very well, speed equal to distance by time. So, time equal to distance by speed. Again, I am telling, as time equal to distance by speed. Is it? Now, students, after that, now capital T equal to, in completing one revolution, now if you know the orbital radius is smaller, so one revolution means how much distance? 2 pi r. And speed how much here? V naught. Is it? Now we'll put the value here. This is 2 pi r. And V naught value how much here? Root gm by r. Okay, that means here we can write here. I will just make a square both the sides. So t square equal to 4 pi square into r square by gm by r. So from here what we can tell, see very easy, t square equal to 4 pi square by gm into r cube. Is it? This thing you have to remember that. Very, very important. Now again I will write here, this side here. So here we can tell students this t square is directly proportional to r cube by m. What is m? Mass of the planet. If in case question is coming and in that they are telling first satellite is revolving around one planet in this radius. Again satellite is revolving around the same planet. Which planet? Same planet. They are not changing the planet. Then only capital M will be constant. So remember that please here. If capital M is constant, they are not changing the planet. Then only what we can tell? We can tell t square directly proportional to r cube or t directly proportional to r to the power 3 by 2. If the planet changed in a question, then we have to use this formula. Please remember that very well. Okay? And this also we have to remember that here. Next one, students, see please, important points. If satellite is very close to the surface of Earth, very close to the surface of Earth, what we have seen that here, small r is approximately how much? Capital R. Is it? So see, as t square is 4 square by gm into r cube. Is it? So we can write here, see please, t square means 4 pi square by gm. And what this will become here? Capital R cube. That means here you see 4 pi square by here gm by r square into r. Now students, you can see very well, this is 4 pi square. What is gm by r square? This is small g into r. So t square is coming here, 4 pi square by small g into r. That means, students, if I just do here the time period here, so t will come here 2 pi root r by g. And if we take the earth, that means r value, as I told, 6400 kilometer, small g 9.8 meter per second square. So this used to come 1.41 r or 84 minutes. Please remember that directly. This expression is very, very important. Number of places it will come. Second one, let's see. Time period of closely revolving satellite depends only on the density of the planet. As I can tell you, see please, as what we have learned, if we see from here, t square is equal to, you just see here please, now see please, 4 pi square, I am taking from here, this one here, 4 pi square by g into r. Now 4 pi square, what is the value of g? 4 by 3 pi rho gr into r. Now this is the value, gravity value, we have to remember that here. Now what will happen that here, you can see 1 4 cancel, from 1 pi cancel, and from 1 r will cancel. That means if you will go, it will become here 3 pi by g into rho, and here t square is there. Is it? Now students, after that, if we will just see here, this t will come how much here? Square root of 3 pi 0. That means here you can see very well the time period is depending upon the density of the planet.